So some more problems using the factor and remainder theorem. So we look at the first one. We're given that 3x cubed minus 4x plus ax plus b is divided by x squared minus 1. There's no remainder. So we're dividing by a quadratic, but it's a quadratic can be split up into two different linear functions. So, and using that idea to find a and b. So we know that because it can be divided by that with no remainder, x equals minus 1 there and x is equal to 1 must be roots of the equation. So if we substitute 1 in, because a root of an equation would equal to 0, and do our algebra and arithmetic here to get down to a is equal to 1 minus b, so we get an equation in a and b, or a is equal to something in terms of b. And again, minus 1's a root, so we can substitute it in and get equal to 0 and get a is equal to b minus 7. So if that's the case, we're able to make those two equal, and taking the b across and subtracting the 1, we get b is equal to 4, so a would equal minus 3. So again, a lot of these are coming down to making sure we can find simultaneous equations. So using that idea. So x plus 3, x minus 2 plus 2 divided by x minus k, the remainder is k squared. So what would be the value of k? So what we're saying, we're going to substitute k and k into for x in both, because it was divided by x minus k. So when it's x is equal to k, we put it in, and it's equal to k squared, the remainder. So that means p of k would equal k squared. So that's what that is basically saying. So we're able to do that substitution. So expand the brackets, we get a k squared there. So the k squared plus the k minus 6 plus 2, well, the k squareds cancel, so that's what was happening with that one. And k is equal to k minus 4 was equal to 0, so k would equal 4. In this one here, we've got a polynomial divided by x plus 2 and x minus 2 as factors. So again, we can set up our quadratic, we set up our equations, because p of 2 from this one would equal 0. So we will substitute 2 equal to 0, and we're able to find that b would equal minus 2a, because we're able to get an equation of b in terms of a. And we're going to do the same with this one. P of minus 2, we substitute minus 2 into that, set it equal to 0, and we're able to get down to b is equal to 2a plus 16. So again, we able to set up because they're both equal to b, minus 2a would equal 2a plus 16. We solve for a, we get a is equal to minus 4, and then do the substitution back to get b is equal to 8. So find the remaining root. So if that's the case though, so again, we're looking at that b was equal to 8. So this is our polynomial written in expanded form. We know we got we've got x plus 2 times x minus 2. So if we did the multiplication there, that would be x squared plus minus 4. So what would go into the bracket to give us this? Well, it's monic, so it must be x. And what multiplies by 4 minus 4 to give us positive 8? Well, that would be a minus 2. So that's where the x minus 2 multiplies to give you x minus 2 all squared. And it's x squared minus 4, which is made out of the plus 2. So we had an x minus 2 and a 2 there. The third root is a 2, which we already had as well. So question 4 here, we've got a polynomial. A and b are missing early on. And we're told x plus 1 and x minus 3 are both factors of px. Using the find a and b. Well, so we do the same thing there. We substitute minus 1 in, set it equal to 0. We find b is equal to a minus 4. We substitute 3 into both, and we're able to get down to an equation in b there as well. So, and then do the substitution of the a minus 4, able to solve down and get a is equal to 3 and b is equal to minus 1. So if we're looking at this equation, trying to factorise it? Well, like we've done before, as you can see, Jun Park probably did this one because he made a little comment for us we haven't scratched out, but that's cool. So it's Jun, apparently. P2, so when x is equal to 2, we make a good guess and gave us equal to 0. That was good, so we know as x minus 2. So, and our quadratic that we must be the other, give me the other factors, we know it's x squared because we got a monic there. Minus 2 times the minus 6 gave us 12. And then as we did, we manipulated before, minus 2 times x, and minus 6 times x gave us the minus 8. So we were able to manipulate and make sure we get the x there. Solve that quadratic, well, it gets x minus 2 as well, and times x plus 3. There's our factorised completely there. And then make a sketch of it. So we know it's going to be that shape because it's positive x cubed there, so we know it goes in that direction. We know it goes through minus 3, and because it's a double root there, it must turn at x is equal to 2. And the last one here, the polynomial here is a factor of x plus 1. Find the value of k, so well, p minus 1 would mean that we get a remainder of 0, so we're able to substitute that in. We've got the unknown k, and able to solve it down to k is equal to minus 2. So all those last ones are just all from exam papers. So that's the type of problems you're going to see in this with the manipulation of the factor theorem and the remainder theorem. So have a look again through them. Learn how to manipulate it and see what manipulations need to go about. There's a lot of algebra going to be involved as well, so you just got to take a bit of care with all those equations.